Hi again everyone, so here's question 2 from our Pulley examples from this morning. Okay, and all I've done so far is I've just started to draw the diagram. So let's have a look at this. Particle A, so here's A here, particle A of mass 3 kilograms, so 3g for the weight, rests on a rough rough inclined plane, and that's really important because that's telling us that friction is involved here. The plane is inclined at 30 degrees, and we're told as well here that the coefficient of friction, so I'm just going to make a note of this so I remember this, the coefficient of friction is 0.1, and that's between the particle and the plane, so between A and the plane here. Okay. Then we've got this light and extensible string, so constant acceleration. The acceleration is going to be the same between A and B here, passing over this pulley at the top. And then we've got particle B here, and this is 2 kilograms, so 2g, that's all I put on for now for the weight. And we're asked to find the acceleration of the system and the tension in the string. So we're going to be looking at resultant forces again, but we again need to make sure we remember here to add friction to this question. The last question that we did was a smooth plane, so there was no friction involved there. So let's put some forces on this. Let's decide on our direction of motion as well. So we've got tension in the string here. And in that last question, I don't think we could put an equal and opposite tension that's acting on the pulley, but I'm not interested in that in this question, so I'm just going to leave my tension acting on A, my tension acting on B. Okay, so what else have we got? We've got our reaction force, where this A is in contact here with the plane, so we've got a reaction force there. I'm going to call that R, and we're going to need that because we need to get friction involved, so presumably F max is going to be involved here. And the system's accelerating, so friction's definitely been overcome, so it's reached F max, so F max equals mu r. We need to work that out as well. The other thing we're going to put on here, then we're going to put that friction on, but I need to decide my direction of motion here. So let's have a little think about this, because this is 3 kilograms and this is 2 kilograms. So actually this one is heavier than this one. So we need to decide, is this system, when we release it, going to go this way down the slope? Or is it going to go this way up the slope? So is this one going to be pulled up or pulled down? And to do that, we know that this force acting downwards is 2g, but I need to compare that with the weight of this one acting downwards in this direction, which is going to be the component of 3g acting there. So I'm going to put my components of my weight, my 3g, on my diagram next. So let's have a look at that. If that's 30, that's 60, so this is 30. So this component's going to be 3g cos 30, and then my parallel component down the slope is therefore going to be my 3g sine 30. So there's the components there. So now what we're going to do, we're going to, as I say, first of all, decide on the direction of motion. Because it's not as obvious in this one, because this mass is bigger than this mass. So let's have a think. Direction of motion. Well, going down the slope here, we've got 3g sine 30, so that's tending to move it in that direction. So let's just do 3 sine 30 on here. Well, sine 30 is a half, isn't it? Don't know why I'm doing that on there. So that's going to be 3 over 2g. But then acting down this way, what have we got? We've got 2g. So this is bigger than this. My 2g is bigger than my 3 over 2g. So this one's winning. The system is going to tend to go that way over the slope. Okay, so and I'm going to put that on my diagram. My acceleration then is going to be that way. So that's what's going to happen here. This one's winning. It's going to be doing that. Okay, so at least we've sorted that out. We've got our acceleration. And it's just a little added consideration in these questions when it's not obvious. Okay. Now we're going to have a look at our components, and the one other thing, and hopefully you're shouting at the screen here, one other thing I haven't put on, I need to put on now is my friction. And again, now that I know it's going in this direction, I can definitely put my friction on acting down the slope. So let's have a look at putting my friction on here acting down the slope. So there's my friction acting there as well. Okay, now let's look at our equations of motion. So let's look at A first of all, and if I look perpendicular to the slope, so if I look at going perpendicular to the slope, I'm going to take away from the slope as positive, then I'm going to get R here minus my 3g cos 30. There's no other forces acting that way, no other components acting that way either, so that's going to be 0. So r is 3g cos 30. Cos 30 is root 3 over 2, so 3 root 3 g over 2. And in this question, I think I'm going to give my answers, we're not asked, so I'm going to give my answers as decimals at the end, but I'm just going to keep that like that for now. So that's really handy, isn't it? Because now I can work out my F max as well. So my friction, it's overcome because the thing's moving. So that's going to be F max, which is mu times R. And mu is my 0.1 here. So that's going to be 0.1 times this. So that's going to give me 3 root 3 over 20g. And as I say, at this point, if you want to kind of work that out as a decimal and store it in your calculator, that's fine as well. Okay, so there's my value of F max. That was perpendicular. I'm just going to move this up a little bit. So now let's have a look at parallel to the slope. So parallel to the slope, my resultant movement is going up the slope. So I'm going to take up the slope as positive. So this was perpendicular. Now I'm going to look at parallel. So taking up the slope as positive, what have we got? We've got resultant force equals ma. So here, my resultant force up the slope, T is winning, so T minus my 3g sine 30. And my 3g sine 30, don't forget here as well, we already know that sine 30 is a half, so that's going to be my 3 over 2g. So T minus 3g sine 30, but also now minus my friction as well, and my friction is this F max, so it's going to be 3 root 3 over 20g. That's my friction being subtracted there. And all of that is equal to mass times acceleration. And my mass for this one, A, is 3, so that's 3 lots of A. Okay, so there's my first equation there. Let me just put this in as 3g over 2, I think. Okay, so there's my first equation. Now I'm going to have a look at what's happening with the more simpler side of this, with the B. The mass B, 2 kilograms. Well, what's happening here? It's moving downwards, so I'm going to tell the examiner, taken down as positive. So 2g must be winning, minus my tension is equal to mass times acceleration. So again, my resultant force equals ma here. 2g minus t is 2a. There's my second equation. And then these two simultaneous equations, I'm going to leave those to you to solve. One as the subject of one, substitute it into the other. I would get T maybe as the subject of this and shove it in here to find A, and then substitute back in. And you should get, I'm going to leave you to do that, because if you've got these equations right, then you're doing it right. You should get, at the end of all of this, I'm going to give my answers, I think, to, I don't know, maybe 2 significant figures. We should end up here with acceleration is 0.47 meters per second to 2 dp, and tension is, sorry, I'm just writing it, so that's going to be 19 newtons, sorry, to 2sf there, to 2sf. But again, when we're back in school, we can talk about kind of what we're going to round these to in the mechanics questions if we're not told. Give a fuller answer first and then do your rounding here as well. So hopefully you've had a go at that question. If you didn't get it right, quite often people, because this one is heavier than this one, think the system's going to go that way. So make sure you get used to doing this in these questions just as a little sort of 30-second check at the start. Have a look. If you've done this and done it right, that's absolutely brilliant. If you've had a go, great. If you were unsure, do not worry about it, but get these into your notes now as some corrected solutions.